Welcome back. This is an Aleks homework video on using the second law to predict spontaneous change. So remember, the second law of thermodynamics essentially is things are going towards maximum disorder. And so the entropy of the universe is increasing, and it's a spontaneous event. So you'll see that in the second law, if you were to write out the second law, you're going to have that the entropy of the universe, or the total unity of the entropy of the universe, is going to be whatever the entropy of your system is, plus whatever the entropy of your surroundings are. So we think of the system as being whatever's in your beaker on the lab bench, and the surroundings as being the air or the space above it or the universe. So if you were to have a fire and that heat is coming out of the natural gas or whatever you're burning, and that heat goes into the environment, then the heat of the surroundings is increasing. You would then have to ask, is the heat of your system, or the entropy of your system, increasing? So the entropy of the system that you're looking at, and then the entropy also of the environment. If both of them are increasing, then this is said to be a spontaneous event. All right, and then I went ahead and wrote the Clausius definition also, and that's that the entropy of the surroundings is simply the heat of the surroundings divided by the temperature of the surroundings. So heat and work, remember, are related, and heat and temperature are related as well. So a couple other things. You would basically only have a couple possibilities. Either the entropy of your system is increasing and the entropy of the surroundings is increasing, or that would be positive and positive, or negative and negative. That's a possibility. Your other two possibilities: the heat of your system would be increasing and the heat of the surroundings decreasing, or the entropy of them, and then or the other way around. So the four possibilities. So if they are spontaneous, if this is a spontaneous event, then it must be the entropy of the universe must be increasing. So I'm just going to write them down. They could either be positive and positive, in which case that would be spontaneous. It's either going to be negative and negative, which cannot be spontaneous. That's exactly the opposite of spontaneous. It's not spontaneous. And then the other two, I don't have enough information to know, because as they play on each other, one is related to the other. So knowing one thing does not necessarily mean that I know the other thing. I would have to have explicit numbers to do math with to find out whether the entire entropy of the universe is increasing or decreasing. So they're giving you basic ideas. They're not giving you quantitative information. They're just giving you just a scenario that you're going to have to guess. So if you can get both the entropy of your system and the universe and the surroundings to increase, you know it's spontaneous, because the entropy of the universe is increasing. If you know that they're both negative, then it's not spontaneous. Those two you know. Any of the other possibilities, you're just going to have to say you cannot decide, that you don't have enough information to decide. Okay? So let's look at this first possibility. So the first possibility says during an exothermic chemical reaction. All right, so exothermic. Exothermic means heat is going into the surroundings. So that's delta S Sir is going to be positive. And then it says 2 moles of gaseous reactants are turned into 4 moles of gaseous. So what is that going to be? So let's look at it. So let me write this down. I've got top of the page the entropy of the system you're looking at and the surroundings, and then what they can be, what I know and what I don't know. I also wrote down a couple things. The entropy of your system, if you produce a gas, we looked at this earlier, the idea of when is it increasing entropy? When you make a gas, you've got increasing entropy. When you're making a mixture out of pure substances, you have entropy increase. And then whenever you have an increase in the moles of gas from the reactants of the products, you're going to have an entropy raise. I wrote down the obvious. It's going to be greater than zero, the surroundings, if heat's absorbed into them, and then if heat is absorbed from them, then it's going to be less than. All right, so this first one says during exothermic, so this is going to be the surroundings is positive. 2 moles of gas are turned into 4 moles of gas. Well, according to the bottom, when gas is produced, your entropy of your system is also increased. That means I've got both pluses. If I've got both pluses, that means it has to be spontaneous. So if it's spontaneous, if both of them pluses, there's nothing it can be but spontaneous, and so this number 1 would be yes. All right. Second question, during an endothermic reaction. All right, endothermic means that energy is not put into the surroundings, but it's being sucked out of the surroundings. So you're going to have a negative, all right, you're going to have a negative entropy of surroundings there because it's endothermic, and it says a gas is consumed and a liquid is produced. Well, from the bottom, if a gas is produced, you're going to have an entropy increase. If a gas is consumed, okay, that's going to be more orderly, less chaotic. You're going to have it's going to be a negative delta S for your system. That means you have both negatives. You're going to have negatives for system and surroundings, which means it is not spontaneous. You can be sure that it's not spontaneous. Last one here, a solid absorbs heat and turns into a gas. Well, if a gas is produced, then the entropy of my system is positive. Okay, so I know that. But it absorbs heat. So it absorbed heat from the system. And if it absorbed from the surroundings, so if it absorbs heat from the surroundings, then that means that the surroundings is going to be negative, and you've got one of these, who knows? You've got the third option here where you have a plus and a minus. I do not know. I do not know what it would be. And with this information, there's no way to know. So if you have both pluses, you know. If you have both minuses, you know. If you have a combination of them, I guess you know that you don't know, which is as good as knowing something. So I hope you know something. Have a great day.